Okay, so question 16, I'm thinking of two different numbers. They are both greater than 10 and their highest common factor is half the smaller number. So straight in I'm thinking, well, if the highest common factor is half the smaller number and the numbers are both bigger than 10, then the highest common factor has to be bigger than 5. So it can be anything bigger than 5, but to make my life easy, I'm going to say, well, let's think about if the highest common factor is 6. Now, if the highest common factor is 6, that would make the smaller value 12. Now we just have to figure out what the other value would be. So another value that is obviously going to be bigger than 12, where the highest common factor is 6, and that would be 18. Both of these numbers are divisible by 6 without leaving a remainder, and there's nothing that divides into both of them that is greater than 6. 16b. A, B, C are prime numbers. Is n always odd? Nope, it is not. Why not? Well, 2 is a prime number. So if C was 2, whatever a cubed times b squared was, odd or even, when we double the value, it will give you an even number. So that's why not. So I would write something like this. 2 is prime. If C equals 2, n is even. So question 17 is about surface area. Now, to find the surface area, I need to know the dimensions of these packages. So I'm going to be using this information here, the fact that each tennis ball, it has a diameter of 64 millimetres. So each tennis ball, its maximum width is 64. So that tells me that this dimension here, which is 2 tennis balls, is 128 millimetres. And it tells me that this dimension just here is 64 because each tennis ball has a height of 64 millimetres because that is also the diameter. Because 2 tennis balls fit going backwards as well here, I know that this is also 128 and I'll use that later. For the cylinder, I know then that this here, this dimension, the cylinder, is 4 64s in length, and I know here is the same, it's 64. So I'll use those dimensions later to find the cylinder. But let's first of all work with the cuboid. Now, to find the surface area of a cuboid, you have to find the area of each of the faces and add them together. So I'm going to firstly work out the area of the front face. Area of front. And when I say front, what I'm really meaning here is I'm meaning this face here. So the area of this rectangle is 128 multiplied by 64. Now that will give me the area of the front. So what I'm going to do is work that out. So that's 8,192. Now the front is the same as the back for this cuboid, for every cuboid. It is also the same as the sides as well for this particular cuboid. So I know that the side is also the same and the other side is also the same. Of course I could have just multiplied that by 4, but I like to get my classes to write down each of the faces so they don't miss any out. Now, the area of the top, or the area of the plan, because the plan view is the view of the top, is 128, because it's 128 here, by 128. So I can find the area of the plan really, really easily. 128 squared gives me 16,384. So I know the area of the bottom is the same as the plan, so I'm going to write that down as well. That is 16,384. So now I've got what each face is worth, I can find the total surface area, and I can find that just by adding all of these areas together. So that's 65,536 millimetres squared. Now for the cylinder. Right, Time for the cylinder. So we have to find the surface area of a cylinder here. Now a cylinder has a closed cylinder has three faces. So we have this circle at the end of the tube, this circle on the other end of the tube, and if I unwrap the tube, I have a rectangle. Now I know how wide this rectangle is because I know it's 4 tennis balls wide. Now 4 times 64 gives me 256. This dimension, the height of it, is actually the circumference. If you think about it, this part matched around the edge of the circle. It's the circumference. So we're going to have to work out the circumference to find the area of the tube. So circumference is pi times diameter. I know the diameter is 64, so the circumference is 64 pi, which means that the rectangle I have here, its area is 256 multiplied by 64 pi. I'll just leave it like that for now. Now, area of a circle is pi r squared. So I need to know what the radius of each of these circles are. So because I know the diameter is 64, I know the radius is half of that, so the radius is 32. So to find the area of the circle, I will do pi multiplied by 32 squared. So if I just quickly work that out on my calculator, 32 squared gives me 1024 pi. Again, I'll just leave it like that for now. So the total surface area here, total surface area of the cylinder is going to be 2 of the circles, because the top and bottom are both circle shapes, so 2 multiplied by 24 pi, add the rectangle, which was 256 multiplied by 64 pi. Now you might be thinking here, why have I not worked these things out? And that's because if I work things out when it has pi in it, I'm going to have to then really round what I've written. And if I round before the end calculation, it might not be as accurate as it could be. So I'm not rounding or working anything out until the very last minute. So I'm going to calculate this now. So I've just calculated it, and it's 57,905.8 millimetres squared to 1 decimal place. So now I can answer the question. I know the cylinder. I worked out previously what the cuboid was. So what I can now do, hopefully, is I can move this out of the way. Yes, I can. Brilliant. And I can see the cylinder, which is in red there, is 57,905. The cuboid is 65,536 millimetres squared. So surprisingly, because it doesn't look like it, but surprisingly, the cylinder has the smallest surface area. So to finish this question, I will have to write that at the bottom somewhere. And obviously you'll be able to hopefully fit all of your working out here, but it's quite difficult on an iPad. So don't forget to actually answer the question at the bottom there.